All right. Good evening, everyone. Am I audible?
Yes, sir, you're audible.
All right. Thank you. So today we are going to continue on the previous discussion that we were having regarding due paths and due pairs, due paths, and how do we figure that out. Okay. So I am planning to describe some examples also, so that I could illustrate some of the special cases also, so that we are aware of how to handle those cases. And that is the plan. And then we'll move on to actually for week two, rather sorry, for week four discussion. There's some topics that I wanted to cover also. But before getting there, I'll just take some questions if you have. Okay, so we can start with that.
Hello, sir.
Sir, uh,
Yeah, one at a time, please.
Hello.
Some Priti, can you go first, please?
yes, sir. I was watching the week three lectures.
Mm-hmm.
So, in the first lecture, at at a timestamp of I think 15 minutes.
Okay.
So there is this example where ma'am is showing a path for the graph coverage. So,
Mm.
sir, in that for loop, uh, and how ma'am is translating that into the graph, there I have a doubt because, sir, in the for loop there is the increment, but according to my understanding, it should be on node three, but it is happening on node four. So, can we see that once?
Okay. All right. Let me. Which lecture is that? 3.1, is it?
3.1, yes, sir. At
Okay.
15 minutes timestamp.
Okay. So you're mentioning a problem on the slide, is it? Is it on the slide or
Yes,
is
sir,
it?
it is on the slide itself, like the
Hmm.
picture. Yeah.
Okay, okay. So let me just share that. No, you can just figure it out from there.
Yes, yes, sir.
Okay. So this one, yeah. Let me know if that is visible. Is it visible?
Yes, sir.
Okay. So this is regarding loop. This one is the for loop. Is this the one that you're talking about from 3.1? Hello.
Yes, sir. I'm sorry, sir. I went on mute. So, sir,
Okay.
I think that for the for loop, that
Hmm.
graph. Uh,
Okay.
before,
This one.
yes, sir, this one. So, sir,
Hmm.
here in the for statement, there is the incrementing that x
Hmm.
plus
Hmm.
plus.
Hmm.
But if we see the control flow graph, so
Hmm.
here at node 4, the incrementation is happening. And
Okay.
the second statement is at node 3. So this is where I am not understanding why it's happening afterwards and not before that x equals to fxy.
Y is equal to fxy is happening, and then only, yeah, yeah, that's the way it works, no? So if you think about it, in the let's assume that you are writing a program, right, in Java. What happens is, first of all, it initializes, right? So x is equal to 0, right? Then what happens? The flow is something like this: x is equal to 0 happens, then it goes to the next part and it validates the condition, with which you are either going to go inside the loop or you're going to skip the loop, right? So for as long as that condition, the middle part, if I can highlight it, this one, right? Okay, so okay, it is selecting in the entire thing, but what I'm saying is the middle part, that is x less than y, is evaluated. So you initialize, then you check. Okay, if only that condition turns out to be true, then you go inside the loop. Okay, if for some reason that condition turns out to be false, which will happen eventually, but if it turns out to be false, then you're not going to go inside. That is what happens. So as soon as you check and you see it is true, you go inside. Now as soon as you go inside, you're going to execute this statement, right? So notice, up until now there is no increment, right? We just initialized, checked the condition, went inside and did the statement. only after the statement happened, then we are going to go to this part, the third part, which is x plus plus, and therefore actually increment happens after the statement in the body has been executed already. Otherwise, otherwise the I mean after that only the increment will happen. Otherwise, if we increment first, then x will not start from 0, right? It will start from 1 then in that case. But we know for sure that x for the first time it is 0 only, right? It is happening only because you initialize, then you check the condition, then you go inside, execute the statement, then you come back and then you increment. And then once it is incremented, then you check the condition again. If the condition is still true, then you go inside again, execute the statement again, and then increment again. So that is what happens. Is that okay?
Okay, sir. Yes, sir. Okay.
So that's why you have y is equal to ffxy first, then increment happens, because that's the flow actually. And then you come back, check.
So, sir,
Number two is the checking of
if
the
it
condition.
is
Hmm.
so, sir, if we get this kind of statement, so first
Hmm.
we have to check the conditions, whatever is present, and we have to enter the loop,
Hmm.
and then only go for increments.
Correct. Correct. That's the way it is. Yes.
Okay, sir. Thank you, sir.
All right, thanks. Okay, so meanwhile, I just stop. Anything else? Any other questions from anyone else like to ask from the up until week 3? Yes, Lakshya, go on, please.
Sir, I'm confusing in DU path,
Hmm.
def path
Hmm.
set, and def pair set. Can you explain?
Okay, okay. Yeah, yeah. I'll do that. That is the agenda actually for today. I wanted to discuss that only because earlier session we discussed that in detail, but that was theoretical. So I wanted to take some examples also, like one of the examples, and then describe it. So that is what I'm going to do. Yeah. So that's all. Anything else from anyone? Otherwise, I'll go to that part. Okay. So I'm assuming there are no other questions. So just give me one moment. I'll share another screen so that I could annotate as well. So I just wanted to take one example and explain some cases for the DU parts. Actually, give me one moment, please. Okay. Is the screen visible?
Yes.
All right. Okay. So I just wanted to, this example is from one of the older question papers. So just taking that one of the quizzes, it is happening. Like this was asked, so just explain it from there. So the first thing is def, right? So where def happens. Okay. So def is definition. So for any variable, wherever an assignment is happening, right? It could be the first time, meaning the initialization itself, or it could be a redefinition. Okay. So for example, so let us consider for x. Okay, so all these questions come only in the context of one variable. Like some variable will be given, and according to that you have to answer. So we'll have to take something, right? So assume that we are talking about x because these things change depending on which variable you are taking. If you're taking y, then things will be different. If you're taking x, things will be different, right? Depending on the graph. So the questions also are parameterized, or rather the du paths are parameterized, as we say, by one variable, whatever variable we want to take, into consideration. So in this case, for example, if I were to take x is equal to a, right? So basically I'm taking x, right? So how many definitions for x are happening? One definition for x is happening at 1 because x is equal to a. That is the first time it is happening. And then I think that is the only definition, is it? No. Okay. So one
And
more
two
definition is
also.
at 2. Yeah. 2 is there also. This was that. And 6, 7. That's all. Okay. So what happens with the du pairs? First of all, you have to understand that. So we know what defs are for x, right? So you consider it like this: def of x, and this will be a set, right? So this goes something like this: 1 comma 2. Okay. And then you talk about use again with the same variable, right? So because we are asking it in the context of that particular variable. So use of x, that's going to be a set. Okay, sometimes we do it the other way around also, taking into consideration the nodes. Okay, so if we say definitions at 1, so x comma y will be the set, right? So we are asking the other question of how many definitions are there at node number 1. But this is a different way of putting it. Both ways are valid, but the reason I have put it like this is because the questions and the du pass are going to be parameterized by the variable. So it is better to take it from the variable rather than from the nodes. Okay, so that is a better way of doing it. So definitions of x 1 and 2, and then we are going to see what all uses are there. Okay, so use is wherever it is being used for any reason. Okay, it could be printing, it could be it could be some increment that is happening, it could be a multiplication, division, anything. Whatever happens involving that variable, you consider it a use. Okay, so then for x we have 2 is a definition, 3 is a use for x, right? Because if you see here, 2 into x, y is equal to 2 into x. That's a definition for y, but x is involved there, right? In the computation. So that's a computation use, C use. That's okay. And then we will have set here. We'll say for use 3, at node 3, there is a use for x. Okay. And then 4, there is nothing. And on the edge also, so when there are conditions, right? So for example, 4 appears to be a if statement. Okay, so what happens is we are checking if x is greater than or equal to y, then we are going to 5. If x is less than y, then we are going to 6, right? Depending on, so this appears to be a if condition 4. Okay, so in both cases x is being used, right? Then only you compare. Unless you use that, unless you look into the variable's value, you're not able to compare, right? So you have to look into that and then compare, and accordingly you make the decision. So therefore these two are considered as a use, right? But the thing is, this is a use on the edge. Okay, so when this use happens, we call it a p use or predicate use, because on the edge you can only have a predicate kind of use, because you cannot do anything on the edge, right? I mean, as in, computations cannot happen on the edge. It is as if we are making a decision, right? So it is just like following a path. So the only use that is possible on the edge is a p use, right? Predicate use. And sure enough, these two are predicates which are being used. So nonetheless, these are still considered use. So when you consider use on the edge, you have to describe the edge, right? The only way you can describe the edge is by using this notation, right? So we have the notation for edge, which is I comma j, right? That's what we say, right? So the starting node and ending node. So that's how we describe an edge. So in this case, 4 5 is a use, 4 comma 5 is a use, 4 comma 6 is a use. So here what you'll say, 3 is the node, right? But if you want to say it for the edge, then we'll have to say something like this: 4 comma 5, and 4 comma 6 is also used for x, right? So 4 comma 6. Okay, I shouldn't have closed it. I think some more uses to it, right? Yeah, at 5 also there is a use. So sorry, let me consider that as well. Okay, for the time being, I'll just remove it. Okay, so 5 also, 5, the node itself also has a use, right? So 4 5 is a different thing. 4 comma 5 is the use on the edge, but for 5 we are considering this z is equal to x plus y, right? So there is a use, and in fact at 6 also we have. So I would write it like this: 4 comma 6, then 5, the node, and then the node 6, right? So these are all the uses. 7 is just for z, right? You're considering x here, so we'll not consider that. I think that's all. And then we can close it. Yeah, I think that is all. So we will close it like this. Okay, that's fine. Now, first thing is du pair. Okay, so du pair is nothing but a cross product of these two things. Okay, because what we said, remember, the du pair is what? Du pair is an ordered pair such that a variable in question, let's call it v, is used at the node ni, rather defined at the node ni and used at the node nj, right? So it is always going to be def comma use. Okay, the order cannot flip. This is an ordered pair. Okay, so you always say def comma use. So I is basically less than j. You cannot have a use before something is defined. Okay, you can only use something when it is already defined in the preceding nodes. So I is always going to be less than j. Okay, you are going to start somewhere and then end at a use. So that's fine. So for example, so then to figure out all the du pairs, what you have to do is basically take a cross product. The only thing is you have to make sure that all the uses are coming after the definitions. Okay, you should not be having a du pair such that the use is there but the definition did not happen. Definition is after that. That should not happen. It can happen, right? If for example, if assume that z is being defined here, right, at 5, this definition. So this definition of z cannot go before it. Like I cannot consider this definition of z with, let's say, something less than 5. So I cannot have, let's say, there's a use for z before 5, then I cannot consider that. Okay, this has to be always def comma use. So that is the thing, and if that is satisfied, then you just take the cross product. Okay, so du pairs for x, how many du pairs are there, and then you just count it. This could be a question, how many du pairs are there for variable x. Then you have like this, right? So I just make it, you have 1 comma 3, that's fine, and you take it individually. Okay, so 1 comma 3 is 1, and then you have 1 comma 4 5 defined at 1. This definition is being used at 4 5, that's okay. And 1 comma 4 6 again, 4 6, and what else we have, 1 5, right? 1 comma 5, 1 comma 5, and then 1 comma 6. Yeah, is there a raised hand? Go on, please.
Sir, sorry to interrupt, but if we
uh,
go to the graph,
uh-huh.
we said we define and redefine. So if when I'm talking about taking pair, I mean
Hmm.
first node, the definition is x equal to a. Now when I'm taking 1 5,
Hmm.
I'm taking x which is redefined also
Add
in
2.
both. Yeah, at
Yeah,
2.
yeah.
So
So
do we take such pairs where redefinition is in between?
right,
How
right.
does that work?
Yes, we do take it. So the thing is, in du pairs, okay, since the definition just says a variable is used, rather, it's a defined at some place and then it is used at some place. Okay, so then you consider that as a du pair. Du pair need not be def clear. I know, I mean, it won't be used as such because when you construct the path has to be def clear. So at the end of the day, that is not going to be used, right? So wherever the definition happen, that will not be used. But then in the du pair itself as such, you consider it. Okay, therefore I said it's just a cross product. So you need not worry about whether it is def clear or not. So 1 6 will actually be considered, even though when you consider du paths out of it, those du pairs will not be considered. Okay, so
Okay, sir.
when we ask for how many du pairs are there, you just consider all of them regardless of the def clear criteria.
Okay, sir. That answers my question. Thank you so much.
Yes. Okay, so that is one part of it. So du pairs, since they did not be def clear, the only condition is use must be after def. That is happening here. So you get that. Hopefully, I have done it correctly. So 1, 2, 3, 4, 5 du pairs are there for x. Now, once you have the du pairs, you are going to construct paths out of it. Du paths. Okay. So du paths are again from def to use. Okay, but they need to be def clear, meaning there should not be any redefinition in between. Okay, so for example, 1 2 4 6. So consider this one, right? This one, I'll just use a different color. So this one, for example, we are considering, right? 1 comma 4 6, right? So what will be the du path for this? This will be 1 2, because you have to construct a path now, right? This is just two instances, two places where it is used, but then you have to construct a whole path out of it. So from 1, of course, you have to go to 2, either to 2 or to 3. That is up to you. And then there are coverage criteria which state such things of whether you have to take all the possibilities and so on. So we'll get to that. But before that, so construct at least one du path out of it. Okay. So let's say if I want to use at 4 6, then I start at 1. So 1 2 4 6 could be one du path, right? But it could not be du path because it is not def clear, right? So 1 2 4 6 is a path like this. So 1 to 2 to 4 to 6. But since there was a redefinition of x in between, so actually the definition at 1 is not being used, right? Because at 2 we redefined it here. At 2 it is being redefined. So then we will not consider that du path. Okay. So that one cannot be considered. Okay. So out of this, you cannot construct a du path from 1 comma 4 6. So that is, we'll leave it at that. Okay. Similarly, you cannot even have 1 3 4 6, right? Because all the two paths which are possible from here, from 1, at both these nodes 2 and 3, x is being rather, sorry, okay, x is being used here, right? So this one is possible, right? 1 3 4 6, yeah. So 1 3 4 6 is possible because here you see it is just a use and not a redefinition. Had that been the case that x is redefined here, then you will not consider it. Okay, so assume that at 3 also you have a redefinition, then you cannot go from 2, you cannot go from 3, so then you cannot construct a du path out of it. But in this case it is okay because it is for y, right? It's not for x, so we can consider it. Okay, so we will consider it. So this path will be what? 1 3 4 6, 1 3 4 6. This is one path, and this is for the definition at 1, and the use at the edge. This is for the use at the edge. Okay, be careful with that. Similarly, 1 4 5 4 5, this edge, right? So again from 2 we cannot go because 2, the one with having node 2 will not be def clear, so we'll go from 3. So 1 3 1 3 4 5 is also a valid path, valid du path. 1 3 4 5, that's okay. uh yeah, so 1 4 6 I think is done. 1 4 5 is also done because you have considered it. 1 3, we will consider it directly as a separate path also, which is fine. So because you define at 1, use at 3 itself, that's also okay. This is for this one, right? Y is equal to 2 into x. And then 1 to 5, again you cannot go from 1. This is about the node 5. Okay, so this will be 1 2 4 5 is not possible. So you'll have 1 3 4 5, but 1 3 4 5 is already considered, right? Therefore we say how many unique du paths are there. It is possible that something is being used on the edge, so of course you have to follow this edge, right? So 4 to 5 you have to go so as to exercise that edge, and once you do that, 5 is covered, 5 is there. So for the use at the node 5 itself is being covered here. So the other path will be 1 3 4 5 itself. So we don't consider that. We will say in the question, we'll say, "Hey, how many unique du paths are there for variable x?" or something like that, right? Then we will say unique. That is what we mean by unique, because you could count it only once. When we ask for number, you give it only for the unique paths. Okay, so because 1 3 4 5 is the same path for this use at node 5 also, no? It so happens in this case. So therefore you consider only unique ones. Okay. Okay, so 1 5 is done, 1 3 is done, 1 4 5 1 4 6 is done, 1 5 is also done. 1 6 will be what? 1 6 is again 1 3 4 6, which is also considered, I think, right? Right, it is a different use, but since the path is same, we'll consider only unique ones. So 3 3 du paths, right? I hope I'm not missing anything. For x, this is for x, by the way. Okay, just let me quickly check. So 3 is considered. Yeah, you just have to see if all the you have considered all possible du paths out of the du pairs that you had. Okay, so 1 3 we have considered already, right? So this is done. 1 4 5 is done. 1 4 6 is done. 1 5 is done. 1 6 is also done. So I think that's about it. Okay, so these are all the du paths for x. Now, now there are three things regarding the coverage criteria. Now this is done. So this is du path, right? Now you are going to have coverage, meaning these are the requirements. These are what? These are the requirements, TR. Okay, similar to how you have prime paths, right? So those are TRs. Similarly, for du pairs, rather for du paths, these are the du paths which are the requirements for the various coverage criteria you have for data flow graphs. Okay, so there are three things. Just want to clarify that. One is all def. Okay, you have to be very careful on this. So all defs. First thing is all defs. Okay. And again, this is all in relation to one variable, because you change the variable, it will change, right? The things will change and so on. So that is what will happen. So all def says you have to consider all definitions, because again for variable x, right? All definitions but consider at least one use. Like every definition of x should at least have one use. Like it should be used at least once. So for example, I can say for x, right? So how many definitions x has? X has at 1 and 2, right? Two definitions. So what all def says, I have to exercise the definition at 1, and I have to also exercise the definition at 2. So I should have a test path such that I use the definition at 1 somehow, and I use the definition at 2. That is what all def says. But which use you're going to pair it with, it is up to you. Okay. It could be that with one, this definition at 1, you could have multiple uses, right? You can end at somewhere, so end at some node where it is a use. But which use you end up at, it is up to you. Because all def just says you have to exercise the definition. How you're going to exercise is up to you. Okay, so you could maybe we start with 1, right? So we could end at, let's say 3 itself. That suffices. So I could have 1 3, right? So 1 3 is a is one du bar that is going to do for this definition of x at 1. And similarly I have to consider at 2 also, no? So this one I can consider, let's say 246, for example, right? Because I'm considering this definition. I think I missed one more portion of the thing, right? Yeah, these are the paths with one, with the node 1 being the definition. You have to consider from 2 also, right? Therefore I said cross product, so you have to check from 2 also. Okay, so you'll have 2 3 as well. uh do we have 2 3? 2 3 is not possible. 2 4 6 you can consider. Okay, from 3 it is not possible, right? 2 4 5 is possible. 2 4 6 is possible. 2 and 5 and 6 both are considered, right? Yeah, so two more. 2 4 5, and these are the du paths. 2 4 6. This is for the other definition, I missed that earlier. Okay, yeah, because there's the definition at 2 also, you consider it separately. That's fine. Now what I'm saying for all defs is you have to consider 1 and 2, right? So any use you consider. So I want to exercise the definition at 1, so I can take any of the uses. I have taken 1 comma 3, so that suffices for one definition, right? And I have to consider the definition at 2 also, because there are two definitions for this variable. So with 2 I can consider any use which is possible. So let's go to check that. Maybe I'll select 2 4 5. I could have gone with 2 4 6 also, anything. Okay, 2 4 5. So I'll consider 2 4 5. Okay, these are the two paths. Okay, now I have to consider test paths, and these are the requirements for all defs. If I somehow have test paths that tour these du paths, then I will say all def coverage is achieved. Okay, so these two paths are required. And similarly, to run that test case, to actually exercise that test path, you have to have rather to exercise that du path, you have to have a test path, right? Again, what is the definition for test path? It must start at the initial node, must end at the final node. Okay, this is the requirement for a test path. So what we'll do, we will extend it. Okay, so we know this is the path that we need to tour, so we'll just extend it, make it into a test path. Okay, how we extend is up to us, because this portion is included, right? 1 comma 3 is included. Then we just extend it. So let's say I could make it like 1 3 4 5 7. Okay, so I'll make a test path out of it, because I'm just interested in this use at 3, right? So any test path will do. So 1 3 4, right, 6 7. I have to end at final node also. That's the requirement for the test path. And for 2 4 5 again I have to make it. So let's say, and I have to start at the initial node. Okay, that's the requirement for the test path. So 2 4 5 has to be there. And from 1 you can go to 2, right? Yeah, you have to be careful about what is possible, what is not possible. Okay, to look at the graph and then accordingly construct the path. 5, after 5 we have 7 directly. Okay, that's fine. So we'll do that. Okay, so these two test paths now together satisfy all defs coverage on this particular data flow graph. Is that clear? This part? This is only one of the coverage. There are 3 coverage criteria. So I'll describe the other 2 also. This is the first one, all defs. Is this okay? Any confusion? Yeah, go on,
So
please.
a
You go on.
a very trivial question when we say I always get confused with test path and test requirements.
Mhm.
So for test requirements, basically we want to check. It could be any intermediate or a subsection
A
of the
path. Yeah,
entire.
yeah, yeah.
While path always has to start with the initial node and end at the final node.
Final node. So this is your TR. Okay, and this is your
And
test path.
TR should always be present in test path.
Yeah, therefore only you
We
tour
can
that.
make the test path. Yeah.
Yeah, therefore only you
Okay.
say you cover it, right? So
Yeah.
this is as if the user is saying that I want to travel this path, right? The TR is what the user is saying, or I mean that is what the requirement is, right? I said that okay, I want to do this specified path coverage. Then I give you a list of paths. So I said okay, you're going to tour these many paths, right? Then it is up to you to construct the test path, but those test requirements will be satisfied only when you're going to tour that using your test path. Okay, the test paths are the actual execution of the program with the test requirements in them as a subpath, so that we say that these things have been toured, like we have gone through that, as in followed that.
Yeah,
You understand?
got it.
Yeah.
And so one more question again based on my previous question, though you mentioned we can take any pairs, DU
mm,
pairs,
mm,
but here if we take, say for example, with two,
mm,
so can we take two and three because X is being redefined at two? At the def, we have two objects, one and two, def of X,
yeah.
and use is three. So as a pair, can we take two and three, although they are not connected, or we can take only those pairs which are connected with an edge, like in somehow directly connected or connected from various
Makes
intermediate
sense, makes
paths.
sense. Yeah, yeah, so far we've been only taking those which are having a path, so that's also a good point. I think we can only take those which are having a path. Okay, def clear is not a requirement. Okay, but at least there should be a path.
Even when we are taking pairs of this, right?
When you're taking pairs, please consider only wherever you're having paths. So yeah, that's
Connection.
a good point. Yeah, in
Okay.
this case we don't have it, right? Okay, yeah, yeah.
Mhm.
So this actually falls under the category of having the somehow having the use before the definition. In some sense, you understand what I'm saying, right? So this is like an ordered set, right? And then we say it is not reachable. It's the same as if it is not being defined before it is used.
That's, yeah, that's true. But in this case, sir, for example, if we look at two, okay, then if two is happening,
Hmm.
I'll go to four, and X is somehow already defined, but it is at a previous value,
Hmm.
even
Hmm.
if it
Hmm.
is taking this path. So it's a different definition that we will take
Yeah,
if we
yeah.
come to three.
From here, yeah.
So it
And if
is
we
not that
come
it is
from
not defined, but just a different definition.
different definition, yeah. So 2 comma 3 in that way cannot be considered. Yeah, yeah. Please take only those which are having a path. So that's a good point. I think I overlooked that. Good that you mentioned it. Okay. Always make sure that you take only when there is a path. The def
Okay.
clear is not a requirement. Okay. So even if there is no like there's no def clear path, you still take it as a pair, even though that will not be considered as you have seen already in the test path and requirements.
Okay.
So this is done. Um, yeah, because TR is what? TR is your DU paths, right? So DU paths have to be def clear by definition.
Mhm,
Therefore,
mhm.
only you have that. So this is what? This is all defs. Now we'll move on to the next one, which is all uses. So all defs we have seen. This was the first one. All uses is okay. All uses says okay. So there's a slight nuance there. Let me just confirm it once from the definition. Okay. Coverage criteria. And the third one is all DU paths. I'll just write that down. All DU paths. Okay. Yeah. So the thing with all users is, as mentioned on the slide, mm, let me quickly take a look at that. Yeah, all users requires us to store at least one path for every def use pair. Okay. So what you are going to do here is that you are going to go through all uses through all definitions. Okay. Here what we did in all defs was the other way around, right? In all defs we said you have to cover all definitions and take at least one use, any use, that's okay. So I want to cover one three, rather three. I mean, three is the use. I want to cover for one. I could have taken something else also, right? From one, I could have taken something else. So assume that, how do I put it? So assume that there's another use at four, let's say 4x, right? Then I could have taken 1 comma 4 also. So the use, there's no obligation on us saying that a specific use you want to take. It just says at least one use. So I've taken 1 comma 3. I could have taken other thing also. right? I could have taken 1345 also, or 1346. This is also valid. One use. Okay. So that is one thing in all defs. But you have to make sure you cover for all definitions. Meaning you go through all definitions. So you go through one also, you go through two also. So two definitions, this was the thing. All uses is I have to still go through all definitions. That is still fine. And I have to go through all uses. Okay. Meaning all definitions and all uses. All definitions was anyway the case. I was going through all definitions, one and two. And in all uses also I'll go through one and two, but I'll this time I'll not have one path. Rather, I will have all paths with that definition. All uses with that definition. So for example, for all defs, that's what you have. For all uses, for one. So how many definitions are there? Two definitions are there. Which are those definitions again? I'll just write that down here. So you have one and two. These are the definitions. Okay. Now all uses says I'm going to go through all definitions again. So I'll start with, let's say, one. In the first turn, I start with one, right? And I go through all possible uses with one. So how many uses are there with one? 1 3 is one use. 1 4 5 is one use, right? And you 1 4 5 is the edge, right? And 1 4 6 is also a use, right? What else you have as a dupe pair? 1 4 5 1 4 6, right? 1 3 is there. Yeah. So because all definitions we were anyway going through that, and now all users says I have to go through all users also. So it turns out what happens is effectively we are going through all du pairs now, which was earlier not happening. Earlier we were having a choice to whichever we want to you want to select, you can select it with all defs. Here all users says you have to go through all defs and all uses. So this is only for one. Then again you go to two. Okay, with two you have to go back to the graph. Two you have yeah, I've already listed it, right? With two I did not pair it, is it? Okay. Yeah, 2 3, as somebody pointed out correctly, is not possible. 2 4 5 is okay, and 2 4 6 is okay, and 5 6 anyway is covered, right? In 2 4 5 and 2 4 6, so that's still fine, right? So you have for all users 2 4 5. Sorry, it's becoming a little cluttered, and just clear it. Guide. Okay. 2 4 6 and 2 4 5 also. Yeah, these two are for the definition at two, at node number two. Okay, so in total you are going through all du pairs. That is what is happening, right? So this is all uses. Now what is all du paths then? All def says you have to go through all definitions, whichever use you want to use, you use that. There's no obligation. All users says I have to go through all definitions and all users also, through, we have to go through everything. All du paths then says this is paths. So these two were like, talking about du pairs. Okay, this is talking about du pairs, but all du paths is talking about the paths now, because there could be multiple paths also to follow, right? So I'm not sure if we have an example. Yeah, we have it here only. So for example, what happens to all du paths is these two are clear, first of all, right? All defs and all uses, is that okay up until now? Before going to the third one, I'll just take a moment to understand if this is clear. This is okay? Defs and uses? Anyone? Any questions?
So can you just scroll down to all depths that you had listed down?
All devs, right? Yeah, this one.
This is all depths that we have taken. 1 3 1 4 5. These are all depths. No, these
No,
are just the Cartesian product.
yeah, these are just the Cartesian products. All devs we had listed it, right? No, all devs were here. These are the two. These are the two. These are the two for all devs, right? These are TRs for all dev. Because all dev just says you have to exercise the definitions, right? So one and two. That's it. Which use you're going to, follow, it's up to you. You understand what I'm
Okay.
saying?
Yeah. So basically, we have to just take all those points wherever these variables are defined.
Defined, right? And use is up to you.
Okay.
Okay. This
It
is for
can be
all
one
devs.
or more. Okay.
It can be one or more, at least one. That's
At
what you
least one.
at least one.
Okay. Okay. Okay.
At
Now
least
it
one.
is clear.
Yeah.
And for uses, we have to take all the uses.
All the users. So by definition, since we're already taking all devs, and then it says we have to take all users also, so it effectively becomes all du pairs.
But sir, in case of all devs,
Hmm?
I may not necessarily take the use. I can just take one use. I may not take another use. So I cannot include it in all use. No? For example, 246,
Hmm?
we haven't included here in all dev because we've taken 245 already in all dev.
Hmm, that's okay.
That's okay. But if we
Hmm?
are trying to take uh, all use,
Then you have to include that. That's what you have to
yeah,
include.
so this will be subsumed in there.
All users subsumes all diffs. That's why it says all users actually subsume all. Yeah, all users subsumes all diffs. So this is something like this. If you have done all due paths, okay, all due paths. So this subsumes all users, right? And this subsumes all defs. Sorry about that. I just want to move it across. So we have to select it. Okay, I'll just remove it for the time being. Yeah, that's okay. So the subsumption is something like this. Okay, so all due paths, all users, and this actually subsumes all defs. So what happens is if you have done all due paths, then all defs is automatically done. If you have done all due paths, then all users is automatically done. If you have done all users, then all defs again is done. All users, of course, that is the case. If you've done only all defs, then it's not the other way around. This is
What?
the basic one, basically. You
Got it,
understand?
sir. Yeah,
Hmm.
yeah, yeah. Thank you. This clarified.
Yeah, yeah. So that is so all defs you've seen, right? One at least one use that is, but all defs. So all defs is already there everywhere. So you don't even need to question that. You have to necessarily go through all definitions always, whether you're doing all defs or all users or all due paths. Okay, so you start with one and then you go to two. With the other definitions, you go to and so on and so forth. So you keep going, and you consider all of them. That is the thing. So that is already there. All defs is at least one use that we have considered. For both the definitions, we have considered at least one use, right? So one question, quick question. So assume that there are 5 uses in the data flow graph, and I'm trying to do all defs. How many paths minimum? How many? What is the minimum number of paths that I'll require? There are 5 definitions,
5 parts minimum because we'll have
right?
to at least take. So
Yeah.
one more question.
Hmm.
For example, we say in this the basic criteria is every definition should be followed by an use. If, for example, there is one particular situation where it is defined
Hmm.
uh, but not used, can
Oh, okay. Okay.
how do
That's
we handle those? For example, in this only we say not this say example there's a code uh, and then there is one condition which checks if x is less than 5 keep doing this,
mm-hmm.
and if it is less than 5 at the
Hmm.
end after checking all the condition it
Hmm.
straight away goes to the next point where we say x if it is less than 5
Hmm.
it executes certain things, if not x then 5.
Hmm.
So in if condition we just have if, we do not have else.
Makes sense. So you're saying that what if there is there's only see.
If there is some redefinition and there is no use after that, if we assign that final value and then we are taking that final value, after that we are not using it anywhere,
There is no use,
could
then
there
how do
be?
you exercise that one, that definition? Is that
So
what
if
you're
it is
asking?
passed on to some other
Hmm.
component or something, if and
Makes sense.
I'm just checking this, if I'm doing some, for example, unit testing. So in
Hmm.
that unit, I'm just changing the value of the variable. However, I will use it in some other component. So for that particular unit testing, it may
Hmm.
not necessarily be in use there.
Makes sense. Makes sense. Then how you do
So
all
how?
depth, all
So
devs in that case? Hmm.
yes.
So two things. Yeah, it's a good point. One is that one is so two perspectives. One is when you're going to define something which is not used, right? Then there's a warning in the basically in the program itself. It says that definition is unused definition. So it is defined, but it is not used. You can have such situation, but if it is not used, then it is pointless. I mean, we can even remove that definition because it does not make sense. The other case that you're telling about that you're going to use it somewhere else, then you have to expand the scope of your data flow graph also, and then the use will be there, and then you cover over that because this will not give you the entire picture. But the other thing is uh, if there is a definition somewhere, right, and you're saying that that is the last one and after that there is no use for that. See, the thing is, with the other things that is happening, because you're talking about in redefinition in between and so on. So you must have a larger path then that will somehow subsume it, even though there is no use. We will go through that definition. You understand what I'm saying? So, for example, assume that there is a completely different variable here. Let's call it p. Right? P is being defined something 10 right here. Now, now this is just a definition. I'm not going to use p. No, there's no use for p here. Just define it.
Hmm.
Right? So how do we do all this for p then? It does not make sense because, see, first of all, you won't even have due pairs to start with, right? Because due pairs says you have to have def comma use. So even due pairs are not defined in such situations because you have to end at a use. If there is no use, there's no due path and there's no coverage criteria. So this does not make sense, first of all. The other thing is, since you're anyway going through other paths, which will somehow, cross this thing. So 1346, for example, will actually cross this definition, right? So in that way, it is there. I mean, it is captured, but it does not make sense to have coverage criteria over something which is only defined and not used because your due pairs are not there, right? So even the definitions for due path, it says you have to start at the definition and end at a use. Then only you have a due path. If there is no use, then you cannot actually cover all depths. And if you cannot cover all depths, the other criteria you cannot do. I mean, you cannot do that basically. It's not possible.
Okay. Okay, sir. I have particular example in mind. Maybe next session I will just put that across in a
Huh.
proper way before I can ask this. But if I'm
Okay.
taking only this unit, then obviously it will not make sense.
Yeah, exactly. Yeah, other unit if you have, then you have to consider
Then this
that portion of the graph.
definition, yeah, then this definition can be part of the extended,
TFG, all the
yeah,
data flow
okay.
graph. Yeah.
Huh, okay,
So
okay,
that you
sir.
consider. Okay.
Okay.
Yeah. So that was a good question. That is for all defs. Yeah. So the last thing that is left is all DU pass and how it is different. So again, recap. So all defs, what we said, we exercise, go through all definitions, whichever use we want to use. You have to include at least one use. And you said correctly that if there are 5 definitions, then at least 5 paths we will require if we are going to just do all definitions. Okay. That is done. All uses says you have to go through all uses, all definitions and all uses pertaining to those definitions. Then it will require as many paths, at least as many paths as there are due pairs, right? Because you have to cover all, exercise all due pairs, right? All due pairs you have to exercise, so that many paths you will require. All due paths is a different thing. All due paths says if you have multiple possibilities of covering the same use, you exercise all possibilities. So for example, if I consider, so what should I consider? If I consider, yeah, so let's consider for x is equal to a at 1, right? The use at 6, this one. So I'm considering du pair 1 comma 6. This is the du pair, right? So there are multiple du paths out of this du pair. Okay, this is not similar to all uses, because all uses was saying you're going to go to different use. How many ever uses are there, you consider that. So for example, I go to 5, I go to 6, all uses I'm covering. All due pass is saying a different thing. It is saying even if you're going to the same use, you make sure you do it through all possible paths. So that will be what? That will be 1 2 4 6, right? So this becomes 1 2 4 6, and this is for the same use, right? And 1 3 4 6. Sorry, 1 2 4 6 is not possible. So we'll consider something else. Let's consider for y. I think y is fine, right? Um, I mean, in this case, there's a redefinition in between. Assume that this is not there. What I'm saying is not relevant to that. What I'm saying is that if there are multiple def clear paths which allow you to exercise the same use, you exercise all of them. So 1 2 4 6 and 1 3 4 6. It's for the same DU pair, right? Because you have multiple possibilities of reaching the same use. So you consider that. This is all due paths. This is the difference between all uses and all due paths. All uses just says that any path you follow, but you make sure you follow all uses. You reach all uses. All due paths is saying you reach all uses through all possible paths. Okay. So that is the difference. And therefore it subsumes all uses also, because due paths is even more exhaustive. It is saying through all possibilities I'll reach all possible uses. So therefore, all uses are anyway subsumed, because it just says I have to reach all uses, and I can select any one path to reach my use. Every use from within that. And all defs is just saying that I have to cover all definitions and at least one use. So if I were to just summarize, it will be something like this. All def says you cover all definitions. Okay. So this is all definitions. One use. Sorry about the bad handwriting. Okay. So all definitions and at least one use you use. All uses says all definitions. Anyway, you're going to cover all uses. At least one path. So this is like one path. Okay. At least one path you have, one due path you have such that it goes through all uses. Meaning for every use you have at least one path. Okay. So let's say there are four uses. So you assume that there's only one definition and there are four uses. So you consider all the different paths so at least one path for that use, right? For every use that is there. All du path says that I'm going to go through all definitions. Okay, this is already there. All uses through all possible paths. So this is only all paths. You understand what I'm saying? Is that okay? Is the idea clear? Okay. So because you have multiple choices as well there. Is it clear to everyone? Any question?
Yes, I got.
Got it. Okay. Anyone else? No other question. Lakshya, is it clear to you as well?
Yes, sir. What is def pair set?
Def pair set is this, right? The
Cartesian
du,
product.
the Cartesian product of your this thing. Uh, the definitions and uses, right? This one. But
Okay.
again, you have to make sure that there has to be a path there. Uh, That situation will not be there in the questions, but it's good to know that. So there has to be at least one path, then you consider it. Def clear is not a requirement. Okay, and def clear, I hope everyone knows what it is. That in between there should not be a redefinition of whatever you want to consider.
It's a def
Okay,
paths.
sorry, which one? Def
Uh,
paths.
path set.
Def path set is that right? The du path set, basically this one, right? So what happens is, okay. So here you have a definition for it, right? The NINJ, this one, du. Must have seen it on the slide as well. So it goes something like this. Let me just put it this way. Okay, so there is a thing which is like this. Okay, so you have du. Okay, I'm not sure if v is first, but anyway, the idea is that you start with an I and consider this. So it says this is the def. Yeah, this is the def pairs. This is the def path set. Okay, it says all du paths, right, that start at the node I for that variable. Okay, it is not talking about the use. Every use. So you'll have everything there. That for a specific definition for that particular variable v, every use that is there, right? So you consider that. The other one is something different. The other one is du ni, sorry, ninj, ninjv, right? So this says that all du paths that start at the node ni and end at the node nj with respect to that particular variable, right? So this is a subset of that. Like the below one is subset of the above one. Because above is not talking about any particular use. It just says, I'm going to start at that node and every possible du path I'll take from there. Okay, so that is what you have. Is that okay?
Yes, sir.
And the def pair, so these two are the def path sets. The def pair set is just that, right? This one, the du pair set. Um, how is that? Ni, comma nj, where where I is less than j, right? And at ni you have a def, basically, nj you have a use. So this is the pair. This is not a path. Okay, but a path looks something like this, right? So you start at ni and there are intermediate nodes in between, and then you finally end at nj. This is what a path looks like. Okay, so you start at the definition and a use, and end at a use. But this is just in the due pair. So this is the due path. The other thing is there could be in between, there could be multiple uses. Okay, so maybe there's a use in between here also. It's possible. Some nodes, intermediate nodes, you have a use. That's still possible, but there should not be redefinition, because if that happens, this will cease to be a due path. This will not be a due path then. This will not be a valid due path. So then we cannot. Due paths by definition have to be def clear. Okay. So everything that you see in this du of ni comma v, or du of ni comma nj of v, is basically all the def clear paths, because these are the paths. And the def pair set is basically your due pair set. I mean all the due pairs. This one, the Cartesian product. Yeah, this one, the Cartesian product of this. Is this okay?
Yes. Okay.
All right. So yeah, these three coverage criteria you have to be careful about. So the thing is, what we can ask is, we'll have a graph, something like this, and we'll have test paths. Sorry, we'll have test paths like this, and then we can ask which of the following coverage criteria it satisfies. Okay. So there are two ways to do that. You can just trace it and see what all it follows, and you have to be careful about certain things. Okay, if it is just going through all definitions and it is not reaching every use for every definition, meaning it is not going through all due pairs, then it cannot be all uses. And if it is not all uses, it cannot be all due paths. So you can only give all tests for that. Okay. If the number of test paths, first of all, it has to be equal to the number of due pairs. Okay. And if it is going through all due pairs, right? You see that it is going through all due pairs, meaning it is going through all definitions and all uses. So then it could be all uses. But again, you have to be careful. If it is not going through all possibilities, you see that okay, it is passing through all due pairs, discovering that, but there are other possibilities, other paths that have been not been exercised. So that cannot be all due paths. Okay. So you have to then say all uses in that case. But if you see that basically I'm going through every use and all possibilities are also exercised, then in that case you say that this is all due paths. Okay, so these are the three things, three coverage criteria, and the questions could be on this. Have to be careful about that. I think that suffices. Yeah. Anything from week three? What do you want to ask?
So how do we connect it with prime parts in this case? So we'll just again for the parts that are given, we can check for the prime parts, right?
Yeah. I mean, it's a different coverage criteria altogether. So it might not be directly related to prime pass. The other way is true. So the thing is, if you are doing all due pass, you might or might not be doing prime pass. But if you are doing prime pass, the nature of prime pass is such that if you do prime path coverage, then all due pass is subsumed. Okay, so this goes something like this. You have all these three, right? These three, and prime path goes above it. So you have PPC, which is prime path coverage, and this subsumes all due paths. So if you do prime path coverage without even paying attention to the definitions and uses, uh, that is a nice thing that it also does due paths for you, all uses, and therefore all uses, therefore all defs. Okay.
Okay. Okay.
So, but the other way is not true. So if you consider all due paths, it might not be prime path or prime,
Hmm.
only due paths you do, it might not cover prime path, all prime paths. Okay. But if you do all prime paths, then certainly due paths is covered.
It automatically covers those.
Yeah, it automatically covers those. But
Okay.
having this annotation and having knowledge about how many due paths are there, how many unique due paths are there, and due pairs are there, and so on, is still good to have, because that kind of gives you a different perspective into the CFG. The thing with prime path coverage is you don't have the knowledge of the variables, right? I mean, which variables are defined where and where it is used and so on. We just abstract that out and say that okay, this is my structure. I'm going to do a structural coverage criteria, which is prime path coverage, and just exercising that. But I don't really know what is the data involved there, and where is the definition used and so on. Right, so that does not happen. But in this case, if you do prime path coverage, rather if you do due paths and all, then you exactly know where the definitions are and where the uses are. So that can be helpful in some of the, revealing some of the faults which might not be revealed only using structural coverage criteria. Now you might argue and say that we've done PPC only if we do that, then those faults could be revealed as well, which is still true. But yeah, those are two different coverage criteria. But it so happens that it does subsume it. But both are having their own merits and demerits. So
Got it, sir.
yeah.
Thank you.
Okay. So yeah, with this we'll close. I was hoping I could just go through some portions of week 4, but that we might do in the revision session as well.
So week 4 is not released at all.
Week 4 is not there, right? No, the thing is, we'll have. Yeah, there's still some time for the revision session to happen, right? Okay, there was a break in between, no, of a paradox. That's why
Mm.
uh, there's a slight delay. Okay, all right.
Okay, thank you.
Yeah, sure. So we'll go through that maybe 2 weeks from now onwards, right? Because you all might need 1 week to go through that, no, at least.
Yes.
Then only, yeah.
And when
All
are we
right.
expecting to release week 4? Is this week or the following?
Yeah, it should be out this week only. This Friday, hopefully, it will be.
Okay. Okay, thank you, sir.
All right. Thanks so much. Hopefully the explanations were clear enough.
Yes, yes. There were a lot of confusions and questions, but this helped.
All right. Thanks.
Thank you so much.
Thanks. Bye.